Hey, what is up, you guys? Welcome to another episode on this amazing channel. Guys, we're going to carry on with trig, and this is just one of the questions. I think we're just going to do 1 up to 3. So this is the grade 11 textbook, okay? I just want you guys to get a refresher, before we actually get into 3D, and hopefully you guys can see what's happening over here. Yes, so you can see there's a structure over there, and the question is calculate the height of the cliff to the nearest meter, and the height of the cliff is basically AB, okay? And if you like, everything is already plugged in. So in order for us to calculate the height, obviously we're gonna have to do some work. So but one thing I can tell you is that if we can find AC, we'll definitely be able to use trig to find the height. So with this angle given, definitely we can find that angle over there, right? Using the fact that we've got the sum of angles on a straight line. So if we assume that this is x, if we assume that that angle over there is x, then we can find x, right? So x plus 180 degrees must be equal to, not 180 degrees plus, but x plus 57 degrees. This must be equal to 180 degrees. So x is basically what? 180 degrees minus 57, which is what? 121, 113, right? Yes, 113. I believe that's the correct answer. So 113 plus 57 must give you 180. So we already know what x is, right? So now that we've got the x, then in fact we weren't supposed to find the x. The angle that we really need, it's that angle over there, okay? It's that angle over there. And if we assume that that angle is y, right, we can say, okay, fine, we know that 39, right? Okay, let me write this out. We know that 39 degrees, which is that angle over there, plus y must give us 57. Y, exterior angle of a triangle, okay? And then push this forward a little bit, and then so now that we don't have y as yet, but we can find it. So 57 degrees minus what? 39 degrees, and that's going to be what? 50 minus 30, that's see, now I'm wasting time because I'm trying to calculate this myself, and there's going to be some inaccuracies. 18 degrees, okay, 18 degrees. So that's our angle y. So now that we've got the angle y, you guys, we can actually calculate the side AC. Remember I said we need AC, right? Yes, and you will see why just now. So we can find AC. How can you find AC? So we know that the y is 18, okay? The y is 18, so we're just going to use our sine rule. So and remember, with sine rule you can either put the lengths as numerators and the trig ratios as denominators. It's all up to you, or you do it the other way around. So but because a length is missing, so I'm gonna make sure that the lengths are in the numerator. It's easier that way. So AC, right, AC over the sine of its opposite angle, which is angle D, right, must be equal to DC over its opposite angle, right. Let's just call it, we can call it sine Y because we've already put y over there, but A makes a lot more sense. This is also equal to AD, right? There's AD, right? AD over the sine of X, that angle over there, over the sine of X. But I mean, we don't have this, right? That we don't have AD, and we do have angle X, but AD is missing. But you see, with this pair over here, the two, one we do have angle what? Do we have angle D? Yes, angle D is 39. Angle D is 39 over there. And if you check, we also got what? AC we don't have. AC, it's what we're looking for. AC, that's what we're looking for. And yes, now we just need to do the substitution. Okay, AC is missing, fine, but angle D does exist, which is 39 degrees. Okay, and this must be equal to DC. Remember, DC is already given. DC, that's 120. So 120 over the sine of A. A is the angle over there, and remember we found our Y to be what? 18 degrees. So the sine of 18 degrees. So now to find our AC, we just multiply throughout by its denominator over there, right? The denominator there, it's sine 39. So AC is equal to 120 over sine 18 degrees times sine 39. That's our AC. So what we need to do next is now that we've got this, the AC, right, we can use the fact that we can use SOHCAHTOA, right, because this is a right angle triangle. Remember, we don't even need to use those rules and all that. This is a right angle triangle. So if you've got this, you can find AB over hypotenuse, that's the sine of 57, and then we find the missing angle. So now let's just calculate this AC. So 120 over sine 18 times the sine of 39, and that is 244.38. all right, and that is meters. And we've been asked to calculate the nearest meter, so that means our final answer needs to be rounded off to a whole number. Okay, so remember, the triangle that we have looks like this. Right angle triangle here, and then this is AC, and then I check, no, this is C, and then that's A, and then our B is down there, and this length over here is 244.38, and the angle here is 57 degrees. So we now need to find AB. Okay, so we're going to use the fact that AB over AC, which is opposite over hypotenuse. Opposite over hypotenuse, that's trig ratio what? Sine of angle C. Okay, so we're just gonna say, all right, we know AB is unknown, so AB is unknown, but AC is 244.38, and this is equal to the sine. Angle C is just 57 degrees. Therefore, AB is just going to be equal to sine 57 degrees times 244.38. So we punch that into the calculator, keeping in mind that our answer needs to be rounded off to the nearest integer. Right, 0.38. So that becomes just 205. That becomes 205 meters. Okay, so we've managed to calculate the height. Okay, yes, so we worked in this triangle using sine rule, and we calculated what the missing length, which was AC. We calculated AC knowing very well that we would then use the AC within this triangle here to then find AB. Do you understand? So you need to know exactly what to find and why you're finding it. Otherwise, you're just gonna drift around and you're not gonna be able to, you know, perform the calculations properly. So now the second problem, calculate the height of the cliff PQ correct to 2 decimal places. So 2 decimal places, there you have it. So let's read and, you know, plug in the information that's been given. So PQ, right? So angles of depression onto the two boats R and S. So R, this is R and S, angles of depression. So meaning that this is 71 degrees, and that's 49 degrees. All right, yes, and then are all in the same vertical plane. Okay, the distance between the two boats, right, is 200 meters. Okay, so from the top of a vertical cliff, PQ, right, PQ, the angles of depression onto two boats. So meaning that R is a boat and S is also a boat. Okay, so now they're saying that the distance between the two boats is what? Is 200 meters. So meaning that from here to there, that's 200 meters. Okay, so what we are going to do is that we're going to focus on one triangle at a time. Okay, and you see now they're saying they want the height of the cliff. We're going to follow the same procedure that we followed with that one. We know for sure that if we can have PR, we can definitely find PQ by using the trig ratios. Okay, but currently we don't have PR, but we can figure out a way, you know, to find PR. Okay, because remember the sum of this angle and that angle gives us 71. That's an exterior angle of a triangle. So we can let this angle to be X. Okay, and then we solve for X. All right, we solve for X. So we do know that, you know, the X plus the 49 degrees is going to give us 71. So we're going to write it down. In fact, let me just redraw the triangle here so that you guys can see it, because that's the triangle that we're going to be working in. So here's the triangle. So here we've got 71 degrees. You guys can see here's the triangle, and here we've got what, 49 degrees, and we know that the sum of the two must give us 71, and we've been told that from here to there it's 200 meters. So this is S, this is R, and that is P. Okay, so x plus 49 degrees is equal to 71 degrees. Okay, and then x is just going to be 71 degrees minus 49 degrees, and let's use a calculator quickly. 71 minus 49, no need to think unnecessarily, so 22 degrees. Okay, 22 degrees, that's the angle over there, 22 degrees. Okay, fine. So I mean, if this is the situation, we can definitely use the sine rule. Okay, because remember the side that we're looking for is this, the PR, and then we've got the corresponding angle over there. So you can just say, oh, all right, not a problem, PR over the sine of its opposite angle, which is angle S, must be equal to the sine of what? The sine, we can't say sine, but RS, which is the side, over the sine. Trig ratios must, if your trig ratio is in the denominator, this side, even this side, it must also be on the denominator. So RS over what? RS over the sine of x, that angle over there, which is also P. So we can do the substitution. So PR, that's what we're looking for. So we don't know the length of PR. So, but angle S, that's 49. So sine of 49 degrees. Right, sine of 49 degrees. This is equal to RS is given as 200 over the sine of x. X is just 22 degrees. Right. So PR is just going to be 200 over sine 22 degrees times sine 49 degrees. That's PR. Okay, so you punch that into calculator and we see what we're getting. So 200 over the sine of 22, right, and you multiply by the sine of 49, the sine of 49, and that's just 402.93 meters. Okay, so now that we've got the PR, I want to show you guys how we can then use it in the other triangle so that we find what they asked us, to find. Okay, so here's the thing. We are now going to be working in the other triangle. Remember, we were working in this triangle, so now we're going to that right angle triangle, okay, which is very easy to work in. So we're just gonna draw it quickly so that we know what we're working with. So P, Q, just a second. So 71 here. Right, so there's the sketch. Okay, that's the sketch of the triangle. And remember, we just found the angle, the side PR, right? So PR is now 402.93. Do you understand? Yes, so this is just that triangle over there. I just redrew it so that you guys can see it properly. So now that we've got the situation, this is easy to solve because we've got a right angle triangle. Okay, so we can use our grade 10 knowledge of the trig ratio. So we know that PQ is what we're looking for. So PQ over PR, and that is opposite over hypotenuse, that is just the sine of R. So we don't know what PQ is, that's the height what we're looking for, and divided by 402.93, this should be equal to the sine of 71 degrees. Okay, So PQ is simply 402.93, right? 402.93 times the sine of 71. All right, and you can just substitute that quickly. 402.93 times the sine of 71. Okay, yes, 71. So the answer that we're getting, that's 380.98 meters. Remember, we're asked to round off to 2 decimal places. Okay, so I was thinking we could go ahead and do number 3 as well. Okay, number 3, but unfortunately we've run out of time. We've gone overboard to already 20 minutes and 55 seconds. So we're just gonna close it off right here, and thank you so much for watching, and I hope you guys enjoyed the video. I hope you gained something. So this is the textbook that we're looking at, classroom mathematics. This is grade 11. So guys, I'm out of here, and peace out.